Yeah. So the lab is officially started already, right? You start using it, or you're still waiting for?
We have all the hints are in the presentation, so we keep the suspense growing, and you will know.
Yeah, I'm so curious now, basically.
Next time you can come to Twente to check if
I would like to.
Or not.
Honestly, I never go there. It's a little bit far, actually.
The far drive.
Yeah. Okay, I think now it's about time, so people can join later. So I will start in case of the time. Okay, yeah, all right. Welcome, everyone. My name is Dong Zhang, the Vice President of EAGE Local Chapter Netherlands. Our President, Yuri Bronkhoff, unfortunately, he couldn't make it this time. So on behalf of him, I will host this online event tonight. So together with University of Twente, we are organizing this online event with two amazing speakers, Mark van der Meijde and Leon uit Scholtenhuis. Well, I will give the floor to them in a little bit of time. First, I will quickly go over EAGE and also our local chapter and some previous and upcoming events. So here, slides. Yes. So before we start, I would also like to thank my colleagues, Yuri and also Aydin and also Florencia for their support and help organizing this event. Thank you. Thank you very much. So about EAGE. So as EAGE is basically a professional non-profit association for geoscientists and engineers. EAGE also provides a global network of commercial and academic professionals with approximately 90,000 members. So EAGE also provides technical communities like our chapters as well. There are lots of benefits. Local chapters like us, EAGE Local Chapter Netherlands, but through the entire world, there are many different local chapters. For example, Local Chapter EAGE Local Chapter London, Local Chapter Paris, Oslo, and Aberdeen, and also Germany. So we have so many different local chapters, but they are all basically senior professional local chapters. We also have EAGE community for the students. So, for example, Oslo student chapters and also DOCS, which is Delft student EAGE local chapters and also SEG chapters. So together we organize a lot of events. We also have events together with the young professionals, together with the students every year. So here are some contact information for our different local chapters. If you're interested to join us, you're more than welcome. So just there's just one tiny requirement. It's better if you can be EAGE membership, and then you can easily join the EAGE local chapter. So here are a little bit more details about EAGE Local Chapter Netherlands, which is us. So we have our own website, EAGE Local Chapter, EAGLCNetherlands.org. We also have our newsletters on our website. So if you're interested, you can always check our upcoming events. Also, it's easier if you can send email to this eaglcnetherlands@gmail.com. We can automatically include you into our list, and then in the future you can always be firstly noticed about our future events. On top of that, we also have our LinkedIn page, so you can easily search us through your LinkedIn. And here are some of our previous events. So this is events collaboration between different local chapters, local chapter Oslo and Paris and Netherlands. We held these events this June in Oslo. So the idea is like to sharing journeys and best practice for organizing and local events. So this is a very nice, it's a success in Oslo. So probably we're going to do it again next year in 2025 in France, Toulouse. So next time probably with even more chapters together to share the experience. And we also have upcoming events, which is the big one. It's called GET 2024. It's very soon. It's in November, early November. So it's Global Energy Transition Conference. So they have different themes, for example, carbon capture and storage, and also geothermal, hydrogen energy storage, and also offshore wind farm. So as EAGE local chapters, we also have a dedicated session in GET 2024 from our local chapter. So a highlight of efforts related to offshore wind farm project in the Netherlands. So you can see here's related speakers already here. So if you're interested, you're welcome to join us in November. So here is today's agenda, of course. So I will first give the introduction, and then there is going to be approximately 40 minutes by our two speakers to talk about the University of Twente FieldLab, an outdoor laboratory for Earth and environmental sciences. And after that, we have about 20 minutes question and answer, and we can discuss. Please notice that if you have questions already, you can use this Q&A. You can press the Q&A button and to write your questions already in the Q&A box. And after the presentation, you can unmute yourself to ask questions directly. So here I will give the brief introduction of our two speakers. First, Mark van der Meij. Mark has a master's degree in earth science from Utrecht University and a PhD degree in geophysics from ETH Zurich. And in the past, he worked at the Dutch Seismology Institute, KNMI, and the Dutch Geological Survey. He started in 2003 Twente University Department of Earth System Analysis and is now head of the Department of Earth System Analysis and also professor in geophysics. His work is focusing on theme of the Earth as dynamic system, where processes inside the Earth and the interaction of these dynamic processes with the Earth structure are of great importance for exploration and all hazards that relate to dynamic subsurface process. Next to his continental and global scale work, he also has an extensive focus on the requirements for the energy transition in relation to climate change. This leads to a focus on much more shallow geophysical imaging and detection. For example, geothermal, but as the challenge that society is facing to transfer from hydrocarbons to more sustainable energy sources. Also, I'll introduce our second speaker, which is Leon Scholtenhuis. Leon is an associate professor in the Faculty of Engineering Technology, Department of Construction Management and Engineering at Twente University. He did his master and PhD at the University of Twente and started in 2016 as a researcher in underground infrastructure network and construction innovation through digitalization. Currently, he's the lead researcher in group ZOARC and Reduce Unit, which focuses on the development and research on reduction of damages to utilities and careful excavations. His teaching efforts are following his research efforts closely. He developed and coordinate the bachelor Smart Ways to Make Smart Cities Smarter, for which Leon and Mark together and the teaching team, they won the team award in 2017. Throughout his research and education, he has close links to industry who are actively engaged in his research projects and educational classes. Okay, with all these introductions, I would like to give the floor to the speakers. I think first, I'll give the floor to Mark. I'll stop sharing. Yes, Mark, the floor is yours now.
Excellent. I will bring up the window, and I think our Leon and myself are a very nice representation of what EAGE stands for. I'm a geoscientist, he's an engineer. We have both been very active in EAGE before, in the near surface organization, have been several times in organization committees, also in geoskills. I don't think that exists anymore, but it was around 2005 to 2010 was preparing on education for the next generation earth scientists. So it's a nice thing. And I think the field lab that I will talk about today And I take a very short moment to do a bit of linking to the broader earth science community, because I'm also vice chair of the table for earth and environmental sciences at NWO, which is advising NWO and the government on earth and environmental sciences. And we have 3 years ago, started with a working community for earth and environmental sciences. And I think few might actually be aware of this, but this might be a very nice opportunity to connect actually to the broader earth sciences community. And I'm more than happy to share afterwards some more information on how you can connect to this. It's completely free. There are already 350, 400 people connected to this. And we share early informational calls, directions of where the government goes with research. So you will be involved, but you'll never be asked to do something unless you volunteer to do something. But it is a nice way to stay involved about how earth and environmental sciences in the Netherlands is developing. That same part is also covering here. So this is about earth sciences, environmental sciences, it's about engineering. A lot of things come together in our UT FieldLab, which hosts over 20 experimental sites at this moment, and the number is growing basically every couple of weeks, months. Yeah, I already put this one. You already gave the extensive. I wasn't sure how extensive it was, so I thought let's quickly put it on. This was the one for Leon. So in the background, this might be nice to look back if the introduction went too fast. But let me first start about what is a living lab. In our case, it's a bit of a quadruple helix where we try to make a realistic experimental test environment. And this came up a bit in a demand or a wish for something that is computer and lab-based, indoor, very controlled, versus the outdoor, which is often has so many factors that you cannot control, and in which you basically lose a bit like, what am I looking at? Is this now an external factor, or is this directly related to what I'm measuring and doing? So this is really something that we try to put in between, and we would really like to involve, basically give it a representation of how society looks like. So there are users, target groups, behavioral designers, there are private actors, there are public actors, there are knowledge institutes, and in a real life context, they come together in this living lab. And it's about to create collaboration, innovation, education, but also calibration, validation, testing of equipment. So basically anything that you can think of, and we will show how broad the scope of experiments is that we are doing. We try to bring that together in our field lab. And we also try to bring together the knowledge institutes, which form the basis, but we have been working a lot with companies and government and users to actually establish what should a field lab be. So there have been over 50 parties, industry, government, knowledge institutes. They have been involved in shaping what we will present today, our UT FieldLab. This is where it is. You see on the blue spots, you see the two faculties on the little square here in the back. And let me put on a pointer. So there. So here is the field lab locations. It's a few hectares large, so it's quite an extensive area. I will show some pictures on the ground. The FC Twente stadium is over here, so you can hear the crowds cheering if there is a goal. Not that that has anything to do with science, but would be curious to see, because we also have, for example, seismometers here measuring vibration to see if we actually see something of the games that are at the FC Twente stadium, or some of the concerts that are held on campus. So this is how it looked like before we started. It was just an agricultural field. So this is from one of the sites. It goes all here and then still goes a long way around the back. So it's really an extensive field, several football fields long. We have a little building over here that will be partly used and is actually becoming a test location by itself with green-blue infrastructure on roofs. And it also hosts some of our storage and meeting facilities. So how did we get to this? And that actually goes a long way back. Actually, Leon and myself were both playing with the ideas on a field lab, and ITC has already many field labs worldwide, where we mainly do not a lot of testing, calibration, but we do a lot of measuring, and we try to link that to satellite remote sensing data and other kind of information that we have field work. But that is basically the real outdoor world. Since 2010, we have had MSc, PhDs, and PDN topics on living labs. And that has been the kickoff for the first designs, where we were discussing what can we do, how can it look like, and it's strongly related at that moment to urban subsurface infrastructure. So I had a very environmental geophysics component in mind, and Leon was very strong on the infrastructure and the prevention of damage excavating. Damages related to excavation. The last few years, a few things came together. There was a funding opportunity in ITC in one of the faculties in 2020. We wrote a proposal. It was decided to co-fund that from the other faculty, the engineering faculty. So the funds that are available add up to about 1.5 million to establish the whole infrastructure, but also establish the experiments. And we received from industry in-kind contributions adding up to over 1 million already. So it's really a large facility. It's also relatively expensive, but I think everybody here knows when you need equipment and measuring outside, this equipment is quite expensive. So when we had the idea ready, we invited people to come with ideas to fill up this few hectares of ground. So we had a first round of expressions where people that had a similar interest to us, could raise their hands. And in two discussions and additional rounds, we basically came to a list of experiments of experiment teams that bundled their forces together, joined the different scientific questions, and we had full design sessions. That was still in Corona times, but people were very enthusiastic, climbing on the tables to get their ideas out there and work on it. So it was really on finding collaborations, finding synergies, because we realized very quickly that certain things can actually be done together. We did a lot of conflict analysis, location analysis, requirement analysis, and I will show some of the 2 or 3 of those aspects that we have studied. We made a full design over the summer based on science and industry feedback. So we also there said like, okay, this is what we are going to do. What do you think of this? And several iterations later, we were working out the details and the organization of the LILA. At that moment was still called Living Innovation Lab. And we finalized the design, including all inputs, after 1.5 years of development. So certain things that we had, and this is the whole area. Previously, you looked from here into this direction. The little building is over here. And we did all kind of analysis, because some experiments need sunlight, other ones do not care or even don't want to do it. So we looked into where is the maximum sunlight, where would you need to go if that is a requirement, and where can you go with experiments that do not need to do this. We looked into hazard management. What kind of experiments do we have, and how do we get onto the terrain? How do we get off the terrain, and how do we bypass certain infrastructure? We also looked into how would we like to organize it, because it is a bit of a natural terrain, and we would like to see that our field lab also remains a bit of a field. It should keep that same flavor in the end. So we decided in the end to cluster the buildings together instead of a dispersion of build-up experiments, leading to the design, the course design that you see here on the left. We also looked at water, electricity, data access, name it. There were loads of different elements that we have analyzed to come to the noise. For example, also interaction between experiments was also analyzed to see that experiments that might influence each other are not directly next to each other. So that came to a technical drawing that looks a bit like this, where we have a lot of different places. Reality now already looks a bit different. This was the first design with which we started drawing. And what you all see in there are a lot of different elements. So there is something on soil mechanics. We have a geophysical test site. We test urban environments, specific experiments related to soil moisture together with Delft. We have an INSAR and GNSS station. We look also for educational perspectives for Twente subsurface, so rocks from the Twente subsurface and some others in a rock garden where we can do measurements, but we can also educate the public. We look at water quality, climate tower, vegetation monitoring, vegetation growth. You already will see a bit of an animation what we do with geoinformation processing in terms of visualization and monitoring. Coastal defense, both from wind and vegetation. So think about the Dutch coast with wind and erosion, but also mangrove forests in the coastal defense with vegetation. There is a greenhouse. There are several stations with radar, sound detectors, and cameras for biodiversity monitoring. We look at the greening infrastructure. It's actually green and blue infrastructure on the house here that is there. About subsurface communication, underground sensor networks. There is a seismoacoustic array together with KNMI. There is a dynamic test field. And we have already taken this part over here was a bonus field that we didn't need for all the experiments. But since then, two big experiments have come up. One focused on CO2 capture by using elephant grass. So that's a project that has started already in spring. And we look at the Hidden Hunger project, where it's a study to actually derive information on nutrient value, because there are a lot of places in Africa, for example, where the soil has been so degraded that any vegetation that grows on there looks like people have some food on their plates, but it has so little nutrients that it actually doesn't feed you enough. And that's the Hidden Hunger project. So we have also a test field for establishing nutrient values. So this is now the more final design on how it looks like. So we have a bit of an artist impression. There were 20 experiments here. So 2 experiments have been headed here in this corner with a lot of internal parties. So ITC and ET are the 2 founding fathers. Also the faculty of EEMCS has joined by now. And we have with KNMI, the Technical University in Delft and Utrecht University. We have also 3 other knowledge institutes, and there is a lot of industry involvement. So this is how it will look like in the end. You see the greenhouse here. This is the little house that was there before. There will be a wind tunnel over here, and there is a water aquatic basin at the back. There are all kinds of towers for monitoring and remote sensing purposes. There are different fields where we will be doing vegetation stuff. So here you see the water basin and a different perspective on the greenhouse. There is the climate tower over here, and you already see it's supposed to be open for public, although probably bikes will not be allowed, but that's a little detail. And this is the bird's eye view. We have organized the lab around 4 main themes that we think are societally relevant, linked very strongly to our challenges that we are facing, but also linked to what the University of Twente is focusing on, and particularly our faculties. So all the different experiments will be signposted with the different themes that we are working on. And there are water and climate, looking at the climate tower, the water basins, water quality. There is urban environment and infrastructure. This is about subsurface infrastructure components, underground communication, the greening infrastructure, food security and biodiversity with the biodiversity monitoring, vegetation growth, the Hidden Hunger project, the elephant grass, and then earth structure and dynamics with all the subsurface modeling components, the ground mechanics, the geophysical test site, the utility test site, the deformation sensors, the acoustic, seismoacoustic network. So everything links to this, and some things also may be linked to more, and they get labeled then double. So these 4 themes will get a big sign, a big board at the entrance of the field lab, where we will explain what we are doing as in those domains at the University of Twente with our partners. So this is just an example of the earth structure and dynamics. These are still in the drawing stage. The real ones will look completely different, but this was the first brainstorm. But it gives you an impression of that it is not only science, but it's also about science communication and involvement with society. At each of these experiments, there will be then a little bit of a board, like a teacher that is drawing on a blackboard with chalk. You will see here that the climate tower has a water cycle and climate earmark related to it. So it's immediately clear what of these main themes this specific experiment is referring to. And then we started with the construction. So after 1.5 years of design and permits and all kind of other stuff, we started with the construction. The site has been largely created in a circular economy way. So we have mostly materials that were remaining at other places from bigger other construction projects, or were taken out somewhere and brought here. So we have got a lot of in kind, and we have hardly had to buy any of the infrastructure that went into the ground. We got also support from a school for excavation machine operators from the SOMA College in Harderwijk. And they have been with us for 10 to 12 weeks, preparing the whole terrain. So they have been practicing there, and in the same time, preparing our field location. So from an educational and circular economy perspective, this was the ideal way of how we wanted to shape our lab. So every week there were 2 or 3 supervisors from the school and up to 10 students every week, and they were going in and out for doing part of it. Sometimes it was very dry, especially the beginning. We had a very wet fall and winter, so at a certain moment it was not possible anymore to go in with the machine, so they had to do it by hand. But we managed to get everything into the ground, and we started with the overall infrastructure, all the power, the electricity, the data cables, the water, everything went in to facilitate access points for all the different experiments. And then the experiment specific parts were constructed. And then I would like to give it over to Leon, because we would like to take you a bit deeper into one of the projects, which we believe is a very nice mix of geosciences and engineering that serves many, many purposes on geophysical studies, but it also helps on engineering purposes and reducing excavation damage, developing new geophysical techniques, new processing steps. So this is one where we believe that for this audience, this might be a very beautiful example to explain a bit more how we have come to setting up such an experiment, what it should facilitate, what kind of feedback we got, and how we managed to organize this. And with that, I would like to give it over to Leon.
Thank you, Mark. Mark, will you keep controlling the slides, or shall I?
I will keep controlling the slides. So if you
Great.
say yes,
Yeah,
I will
yeah.
push.
Okay. So as Mark said, this initiative started off, and maybe I could kind of more or less proudly say that we have this whole field lab with those 20 experiments, largely as a result of our thinking about this utility mapping side, because we felt that across at least the Netherlands, maybe around the world, there are not so many sites where there's sort of a ground truth situation where we really know more about the locations of cables and pipes. And it is quite important when it comes to at least training people in their sort of geophysical skills, and also in their locating skills and detection skills. So like Mark said before, this idea was to create a site that represents the let's say the Dutch situation, And that was one of the first challenges we had. So the idea was we want to train students, and that would not only be education from the University of Twente and those involved or interested, but also from the polytechnics or the University of Applied Science, Saxion, and the vocational schools, ROC van Twente, so the MBO schools, the middle education, college level. And at the same time, we got some inquiries from technology developers, so GPR developers in this case, that wanted to kind of demonstrate that their GPR could do a reasonable good job on detecting utilities. And so far, the narrative was always that it worked well because, well, a client once experienced that the GPR worked well in that condition. There was no real thorough testing of the GPR equipment on a site like for utility mapping. So we were asked, can't you think along with us for a proper way to validate the instrument GPR, in this case GPR instruments, under different conditions? So combining this need to educate people and combining the need to test technology and maybe even improve technology, thinking forwards to maybe other ways of processing data, we really need more of a ground truth. So we decided then to make the utility mapping site. And on the next slide that Mark will probably hit, and will show, is a part of the demonstration of this, some features of this site. We went to various locations in the Netherlands. We had three, 4 big workshops involving all big utility network owners in the Netherlands, so all cables and pipeline owners for gas, telecoms, water, sewage, but also, as you can see, UXOs. So the Dutch Defense and the Dutch contractor Heijmans came, among others, showing their interest in hiding unexploded bombs or even pieces of ammunition below or between gas lines or between cables, as it would actually still occur in cities like Rotterdam. So this led us to take 4 or 5 large iterations, shifting, changing, doing some good inquiry of what an average soil type in a city would look like, and then creating a sort of a final design. So all in all, a lot of industry partners were involved in thinking about what we had to put in the ground to create a realistic situation that was simple enough to train students and at the same time complex enough to also test equipment in different conditions. So on the next slide, you will see the first steps of deploying that, which meant that the students that you see over here started deploying in the nice weather conditions, actually still the sewer lines. They started off with recognizing and locating, of course, the demarcation and excavating the soil. The only things we actually bought were these sewer pipes, and they placed it on a proper location. You don't quite see it in the picture, but the whole bay or the whole pit is 50 by 30 meters, approximately 1.5 to 2 meters deep. And within that, we have 3 types of subsoil, sort of kind of a yellow sand. We have a clayey type of sand, and in between a sand which is more anthropogenic, so containing all kinds of soil with a bit of wood, stone, and debris from, could be buildings or so, mixed through. So 3 different soil types, various bays. You actually see the most simple one now, or a simple configuration now, that's only the sewer. So on the next slide, you see the more detailed drawing, which, we currently use to, we have a more detailed one and an as-built one as well. But what you can see here is that we order all the, so in the vertical direction, you see the keywords top left, vulzand, stadsgrond, kleigrond. These are the sort of directions from north to south, where we have different types of subsoil. And in the west-east direction, we arrange different types of utilities. We have numbered the base B, C, D, etc. until L, and there we actually try and create situations where we have only pipelines, only cables, and then we increase complexity far down to the south, where we have what we call a street profile. So there we would expect there one can expect an underground configuration or a cross section that really looks like a city. So as we would be designing it, as civil engineers would design cities and utilities in the underground. What else can we say is, well, the other thing here is that we have different types of pavement on top. The different types of pavement means actually that we now have blocks of tiles on top of it and grass, and these blocks of tiles are prepared now like it would be as in a normal street, but we can in the future also decide to cover and change those. So that would create the ability to simulate also different type of pavement layers. And also more than that, we can also empty and fill some pipelines to create different contrasts and different situations on the equipment that we use to detect utilities with. One other thing is that we can't fully, because it was just way too expensive. I think the test pit itself would have cost like 500,000 or 600,000 to just build, euros to build. We got a lot of in-kind funding for this, so we were quite happy with all the support from industry. So we couldn't do all the things, but we expect with all this quite deep industry involvement that we are more or less creating 80% of the Dutch situations where, for example, we have different types of cables, different layers, but also different materials and ways to empty them and to fill them in a way. There will be a main switch that allows us to switch on and off the street lamps that we also put around the site, so that we can really, kind of create a realistic situation of undergrounds. Mark has also, I think, one side view, which just allows you to see a little bit from the let's say cross-sectional view from the left or from the west, how it looks like. So what you can't quite read, but what you can trust me on that, is that we have these different types of colors and rectangles with text in it representing different types of utilities with different materials. So PVC, PPE, metal type of cables, concrete, fiber optic, very thin fiber optic cables that we may probably not find, but anyway, we hide it there to just know where it is. And then when all doing this all together, I think we can go to the next slide. Hoping it runs. But what we tried is also to very accurately map the utilities over there. So what you see here is not a GPR color imaging, also a reconstruction using that data, but we just created a LiDAR image from the stuff that has been constructed. So we both have the kind of traditional GPS measurements and the 3D image of this underground. And by having that for each and every bay, so A, B, C until L, this LiDAR, this 3D model allows us eventually to also correlate what we see with the ground truth in 3D. So, now, one of the first questions that Dong also had in the beginning was, is it operative or not? In fact, as a matter of fact, we are already a little bit playing around, sort of unofficially. Last week, we had a guided tour where people used some equipment. Also, our lab manager Jonathan was already using a little bit some GPS, some pulse echo to look into in the underground and see the differences between the soil types and the nice different radiograms that you get from it. Around all this, there is some final construction ongoing. For example, we don't have really yet a street lights, a main switch. We don't have the houses yet, but a lot of the stuff on this utility mapping site is completed. But we are also the first ones, so that means that the other experiments around it, so like the deeper soil or the little bit deeper soil mechanics sites, the other observatories that Mark just explained about, all need to be still constructed. That means we will have to get our final permits, but it all looks quite okay. And then the different types of devices are deployed, and little bit more of a ceremonial opening will be there. In between that, we are rather flexible in just using the space with industry partners, with academics, with students, or maybe companies that are not yet involved. At some point, we need to, of course, think about certain access rights and business cases. But for now, for the time being, we so since everything is not yet ready, we are quite flexible in using it. We give quite a few guided tours for those who are really interested, can come over. If you think about using it in education, in your research, maybe give us send us a message, because we could think and brainstorm about how we could collaborate on that. And in the long run, what we see happening, and also we were having our ideas already on suppliers of GPR or providers of geophysical services. Maybe we would in some time do some kind of a demo session or a comparative session between different instruments, between different companies, where we really have the ground truth that could be used, and maybe even some validation or accreditation of equipment that will be built or improved. That's it. Just content-wise, just to acknowledge that again, this whole site was sort of a crowdfunded project. It took a long while, but thanks to those organizations, maybe not very much into the EAGE domain, but the municipalities of Enschede, the different utility network owners across the Netherlands, which you may recognize, like Vodafone, Ziggo, KPN, GasUnie, Alliander, faculties of ITC and ET, contractors like Heijmans and Sears, material producers like Wavin, School, Soma, and the GPR utility survey company MapExact, and the Dutch Meteorological Institute, KNMI, and the two materials producers, TKF and Wavin, were deeply involved in all of this, and we are still quite grateful that they made all this happen. Good. With that, I'd like to give the word maybe back to Mark with some final comments on the whole field lab. And thank you for your attention.
Yeah, thank you very much, Leon. I can actually add 2 more experiments that are already running. So it is the seismoacoustic array of KNMI, which is also already active next to our utility site, and the CO2 capturing project with the elephant grass is also already up and running. So 3 out of the 22 are up and running, but all permits are in, most of the technical drawings are in. So we expect to open next year summer. And with that, we are very happy to have your questions or hear your feedback about our UT FieldLab and the different experiments. So over to you, Don.
All right. Yeah, thank you, Leon, and thank you, Mark, for very nice and insightful presentations. Actually, I really like it. It's very cool video and cool pictures. I'm very excited as a geophysicist. There's a lot of things we can play with. As far as I know now, it's just you just started basically. Well, I can see you have these experiments with the GPR, with the pipes, and also maybe a little bit of the monitoring. But I can guarantee you there are a lot more you can do in the future, right? So now we're open for questions and also discussions. So all the audience online, if you have any questions, so please shoot. So you can just unmute yourself if you have any questions. Anyone? Well, maybe I can start. But I actually have a lot of questions. Basically, I write a whole list of questions here. Well, you can see it. Yeah. Yeah. First, you said basically it will be open for all the universities and also companies or research institutes, right? So, for
Right.
example, I work for FieldLab, right? For FieldLab, we are for the onshore, which is land part. We are very interested in the foundation design. So, which is a little bit deeper. I think it's way deeper than the pipes. Foundation is normally, I think, 10, 20 meters in the Netherlands, even a little bit deeper than that. So is it possible to also include some sort of controlled experiment for this foundation design, geophysical foundation design survey?
Yeah, in principle, it could be. We have quite a lot of space still left. That's in our dynamic test fields, where we do not have a prefab structure or pre-designed experiments that need to be stable over time. So there's still a large space where things can be dug up, can be put into the ground, can be taken out. It can be shallow, it can be deep. So depending a bit on the sizes that you're referring to, it's definitely possible. Of course, if you're going to do massive stuff hammering into the ground, we will need to check with other experiments that they are aware that something is happening. And we will have a science board that will actually, any experiment that comes in will be evaluated and will be, if allowed in, we'll get also a discussion with other stakeholders on the domain to see if there is a conflict at a certain moment. And this will also all be properly registered, so you can always look back when something was happening. And if you see suddenly something in your data, even if you think there was no interference. So yeah, in principle, it's possible.
Oh, yeah, that's great. Yeah, probably I can also tell my managers about this.
Sure do, and we are welcome to give Fukuro a tour of the facility. No problem.
Yes. So also for Figure, we also have another big business about the offshore project. So in this case, I think can you also like synthetic, well, like mimic the offshore environment, like related to water?
Yeah, we have an aquatic pool where we can actually simulate waves, simulate coastlines with vegetation or no vegetation, create different kind of waves and interactions. So
Oh, yeah.
if that is what you're looking for, there is a possibility to do that also on the lab. Yeah.
So you have a pond. How big is the lake, the pond?
Well, it's an artificial, so it's basically a concrete block. There is also a bigger pond next to it. We haven't taken that yet into our lab facilities, but we are happy to do so. But well, we call it the swimming pool, but I think the owners of that experiment find that not such a nice name. But what is the size of the swimming pool, Leon? 10 by 6, 10 by 8 or so, 12 by 8?
That order of magnitude,
That
yes.
order of magnitude it is.
Oh, okay. I was thinking like maybe more exciting exercise, maybe put some cables like under the lake, under the water, and then to use some methods to detect it. Because that's actually, for example, offshore wind farm, there are a lot of cable lines below that, right?
Yeah.
So it's actually a very realistic environment if you can mimic that.
Yeah.
Yeah.
Well, we don't have really deep waters, but I'm pretty sure that we can do something with the pond and putting something in and do a test measurement. But it will be much smaller scale.
Yeah, I think
as a proof of concept.
Yeah, exactly. I think
sure
5 meter is okay ish.
Yeah.
Okay, I see other people online have questions. Just unmute your Aydin. You have a question? Just unmute yourself.
Yes. Thank you for the talk, Mark and Leon. My question is, you mentioned that you have CO2 carbon capture facilities, right?
Yeah.
The question is, do you also have facilities for carbon storage simulation and testing?
No, that we don't have. No.
Okay. So just carbon capture.
No, yeah.
Okay.
We are looking into this experiment is about, I'm not sure if you're familiar with elephant grass, but elephant grass is one of the type of vegetation that can hold most CO2 of all vegetation types. it grows incredibly fast. And that combination of having a fiber structure that holds a lot of CO2 and its immense growth makes it that it is one of the most efficient CO2 capturing mechanisms in the world. So it's in principle much cheaper and much more efficient than the active mechanical CO2 capturing. And one of the things that we are not directly testing, but that a related party is testing, is to see if you can then harvest this elephant grass and actually bring it like 2 or 3 meters under the ground, inject it into the ground where it's under the groundwater table and where it will just stay for a long period of time, thereby taking massive CO2 out of the ground, out of the air, and put it at depth under the ground for tens of years.
Okay.
So that is the only CO2 storage kind of related thing, but it's all very shallow and very experimental still.
Okay, because right now CCS and hydrogen storage are new topics for geophysics, especially hydrogen storage. So I thought maybe you have some lab and experimental equipments to simulate those kind of monitoring purposes for hydrogen storage, especially and CCS.
Yeah. No, that doesn't really fit in our case.
Okay. Thank you.
Yeah.
Thank you, Heidi. So any more more questions? So I mean, for geophysics, there are a lot potentials, a lot of other, for example, I can think of easily like seismic refractions, seismic surface waves. You can also try to play with all of these for the land experiments, the shallow parts, and also definitely monitoring. Like you can have you ever considered doing like a well logging for shallow wells and to play dust cables into the wells for the monitoring purpose?
No.
But I think that's. I'm
Go
sorry.
ahead.
Yeah, that can be easily done, right?
In principle, yes, we have quite a few wells and boreholes. There is also a ground mechanics site which will have boreholes which are completely filled with sensors to measure all kind of elements at all the different depths, also over time. I see definitely possibilities to easily include this either on that site or in the dynamic test field as a standalone experiment. Yeah.
Yeah. I also have another question regarding your GPR, because you said you already have this GPR application for the cables, right? Have you ever considered, like, for example, to test the resolution of GPR? For example, different size of cables, same material, same cables, but with just different size. And then if you do this exercise, you can actually verify the capabilities of GPR, right?
Yeah. Yeah, we have set up the site as follows. So we have put in all kind of different sizes, all kind of different materials, so we can quite easily see. I'm not sure, we don't have it at centimeter level from 1 centimeter, 2 centimeter, 3, 4, 5, 6, but it are pipes and cables that are realistic. So you can see what is there, but you could also, if you develop something new, test if you can actually see stuff better compared to your previous version that you had. And one of the things that we would like to organize very soon-ish is that we organize a GPR test day at our facility, where we would like to invite users, but also producers of GPR equipment to come and showcase to each other what their GPRs can do, because there is a lot of difference. We had different GPR systems already tested, and you see that there is a lot of difference between Mala, Prosec, and Pulse Echo, and MapExact has an own radar system, and they all give different signals. Even if they are in the same frequency ranges, they are all different. So one of the things that we definitely would like to do is get out there, get to play with radars, but also have the different manufacturers come and explain and showcase what their radars can do, so that for the user community, they can there decide and see like, okay, what works for me? Because now you often, you borrow maybe one from a friend, and we would like to do this with more geophysical equipment, because we have such a beautiful location where you can show so easily what is in the ground, because we know exactly what is there, that you can really see like, okay, how easy is it to use? What is your quality of your data? What is your resolution of your data? All these kind of things you can immediately see. So we are really looking into organizing such kind of test events, bringing producers and users together.
Yeah. Okay. Yeah. Great. Sounds exciting, actually. Yeah. I'm looking forward to that. So I'm actually also like in the future, like I said, like for example, students from TU Delft, they could easily go to your field lab to do some actual field work, field test, right? I guess.
Yeah, that's definitely possible.
Yeah. Okay. That sounds fun. Anyway, thank you again. So it's a very nice, lovely evening. So I really enjoyed. I learned a lot. So
Well, thank you very much for the possibility to share the development and the status of our field lab, and we will make sure that we communicate our official opening to you, and we hope that
definitely.
we can welcome you real time on our field lab so you can experience it firsthand yourself.
Yes, exactly. I mean, for the entire Delft community, we have a lot of ideas we want to test. Like every day, we just play with the synthetic data. We can't easily verify our results. I think that's the whole purpose, right?
Yeah, exactly.
Yeah. Anyway, thank you again. So I'm looking forward to seeing you all in the future, and also looking forward to visiting the lab by myself there physically. Yes. Okay.
More than welcome.
Yes. I will take the entire EAGE local chapter community there.
You're more than welcome.
Yeah.
Let's do that.
Okay. Yes. Thank you again. So have a nice evening. See you in our future events.
Thank you very much. Have a nice evening, everybody.
Thank you.
Yeah. Bye.
Bye-bye.
Bye-bye.